Hello everyone. Am I audible to all of you? Yeah, am I audible to all of you?
Yes, sir. Yes, sir.
Hello. So, is a, am I audible to every one of you?
Yes, sir. Good morning, sir.
Good morning. So, hope everyone is fine. Hello.
I think so.
Did you feel
For me, it's fine, sir.
Did you feel today's earthquake?
Yes, sir. Yes. In
Yes, sir.
Itanagar also, it's
कहाँ पे
happening.
हो तुम लोग? अरुणाचल पे हो कि गुवाहाटी पे हो?
No, I am at Itanagar.
In Itanagar.
Just coming, sir.
Yeah,
In
it's it's effect is also here.
in Guwahati it was very big.
Okay.
Yes, sir.
Where was the sir? Center point,
The
the main point.
epicenter of earthquake was in Thekiazuli. It is. Do you know the place Tezpur in Assam?
Yes, sir. Yes, sir.
अरुणाचल जाने से तेजपुर होके जाना पड़ता है ना?
Yes, yes. It's very close.
So yeah, if you have to cross Tezpur, then on that other side, Thekiazuli is in Dhemaji district. So in that place, what do you call it? It is okay.
Magnitude was high, no? Even in Itanagar, it was very high.
6.4.
Okay.
The magnitude
At the
was.
center point, na?
हाँ. देखिए, I'm very glad that everyone is fine.
सर
हाँ बोलो.
सर
बोलो.
सर ये क्या सर ये हम सर सीबीसीएस सर सिर्फ फिजिकल फिटनेस का ग्रुप बना है सर, बाकी सब्जेक्ट का नहीं होगा क्या?
मुझे तो पता नहीं, वो फैकल्टी बनाएगा ना, जो फैकल्टी किया है ना. The faculty who is taking the class, you'll have to ask that respective faculty for any group or something like that. Yes or no?
But problem is that the faculty name is not given, not even the number is given in the routine.
No,
for the
faculty
optional
name will not
amount.
be
That is the
given because
problem.
it will take by the concerned department. No. Understood?
सर तो सर विद टाइम सर वो लोग वो शेयर कर देगा होगा ना?
हाँ, शेयर कर देगा.
हाँ ठीक है सर.
वो शायद विद टाइम तुम्हें मिलेगा. बाकी लोगों से पूछना तो क्या कर रहे हैं वो लोग. ठीक है. हेलो.
हाँ सर.
ओके. So let us start. So in the last class, we stopped in shear stress. Now, let us study the general stresses at a point. So, if you can see, stress at a point.
सर
बोलो
सर
बोलो
सर स्किन टू विजिबल होना सर
Skin to visible one. Whatever others, are you able to see my screen?
For me.
देख रहा है?
Yes, sir.
Maybe you just disconnect and connect again. I'm sorry. Because most of the people are able to look at it. Okay? Try to disconnect and then connect again. Stresses at a point in a material body is been defined as a force per unit area. But this definition is some. Now, if you see here in this plane, the force that is applied, it is in different directions. Okay, and the force per unit area, it is known as what? Stress. Okay. Now these things. Hello, are you able to see my screen? Hello.
No, sir.
না স্যার দেখা পোৱা নাই
Okay, wait.
Sir.
Give me a minute. I hope you can see now and hear it. Can you hear and see now?
So we can see. Oh yes, sir. Now. We can see.
Fine. So analysis of stress. In the analysis of stress, suppose consider a point Q. Suppose this is a structural member. And you are considering this is a structural member and you are considering a point Q, assuming that the point exists, a plane state of stress exists. That is, the state of stress is described parameters Sx, Sy, and tau xy. That means what? These are the stresses that are existing in different directions. Now, if you can see here, in this dimensional diagram, in x and y direction, the forces are also applied, the stresses are also applied. Okay, so this is how the stress is actually. Why all of your friends join after so long? I have to allow them all the time. It's very disturbing. Now, if you can see this figure, here there are the different stresses that are acting on it. Okay, so now if the different stresses are acting on it, then we'll have to, what we'll have to consider is that, again someone is trying to, is that we are not aware of how the stresses are actually acting. Okay, so in order to determine the maximum normal stress or minimum shear stress, these are the different parameters that we'll have to determine from this. Now, in shear stress, if you can see, this is the diagram. Now, first of all, shear stress is denoted by tau. Now, suppose the bottom part of this is fixed. Okay, give me a minute. Huh? I'm unlocking the meeting because so this part, if it is fixed, then what will happen? The upper part will, if given a motion, given a particular motion, this upper part will start to move slightly. So this is actually known as shear stress. Okay.
Sir, your voice is breaking.
Again, it is breaking. Whatever others.
Yes, sir.
Whatever others, is it breaking?
It's not.
Is it breaking now also?
So it's fine for me.
I don't know why.
So it's fine now.
Sir, ठीक है sir.
Now is it okay?
Sir, when you keep on explaining, sir, it used to start breaking, sir.
Oh, at that particular time only the network disturbs, I think so. Now is it clear? Is it clear now? Is it clear now?
Yes, sir.
Yes, sir.
Hello.
So this is how the stress is and strain is, what do you call it, considered. Okay, now what we'll see is, we'll give you some small examples. So you all know that stress is force per unit area. Now I'm giving you a numerical in the chat box. Just try to solve it. Take out your copies and all. Okay. Can you hear now? I guess everyone is hearing now.
Yes, sir.
Yes, sir. Yes, sir.
So I'm giving you a question in the chat box. Can you see the question? Can you see the question?
No, sir.
In the chat box. So solve it and tell me the answer. Tell me the answer. Okay? Solve it and tell me the answer. So tell me the answer, those who are able to solve it. So what is the answer? Why are you slow? If you have doubts, tell me. Are you hearing me? Students, are you hearing
10
me?
kilo.
बोलो.
Hello.
हाँ
Sir,
बोलो
is it
बोलो.
10 kilonewton meter square?
ये न्यूटन मीटर स्क्वायर में मीटर कहाँ से है यार? ये तो यहाँ पे यूनिट क्या है देखो तो. इसका यूनिट क्या है? What is the dimension of the rod? Tell me, what is the dimension of the rod? Hello?
10 into 10.
Nah.
Mm.
Yeah, it is in mm, nah. So, and
Yeah.
the stress load is given how much? How much is the load given? Tell.
10 kilonewton.
So,
Newton.
10 kilonewton is the load given, right? So, 1 kilonewton equal to how much Newton?
1000.
तो यहाँ पे न्यूटन में कन्वर्ट करने का कर सकेगा कि नहीं? This is 1 kilonewton equal to 10 to the power 3 Newton, right? So just convert this Newton. No? So what is the formula? Tell me the formula first. How will you solve it? This is 1 mark question, you know.
F by A. F by A.
Good. What about others? What is the you wait? What let others? Okay. Someone give the answer again. Good. So everyone should be cooperative. Good. So what will be the unit? इसका स्ट्रेस का यूनिट क्या होगा? टेंसाइल स्ट्रेस का
तब तो न्यूटन मीटर स्क्वायर होगा.
ना मीटर स्क्वायर. हाउ इट विल बी मीटर स्क्वायर?
Because area.
Newton per mm square. The area is in mm, na. Why you are
Okay, sir.
making it complicated? Just someone told me the correct answer. Good, very good. Those who told the correct answer. Good. So it will be Newton per mm square. Got it? So don't worry about it. So the answer will be like this. Okay, is it clear? Is it clear now? So how much is the answer? Tell me.
Yes, sir.
How much is the answer? Tell me.
100.
अरे यूनिट बोलना पड़ेगा ना. बिना यूनिट का कैसे न्यूमेरिकल होगा? Tell me the unit.
100 Newton millimeter square, mm square.
Good. Is it okay? So the 100 Newton per mm square. So Newton per mm square, it can be written in some other unit also, na? What is that unit? Tell me. Anyone, any idea?
Pascal.
No, not Pascal. It is megapascal. Okay. If it is Newton per mm square, then it is megapascal.
Mega.
MPa, megapascal. MPa. Or
Okay.
I am writing in the chat box. Is it clear? Is it clear, everyone? Is it clear? Okay, fine. Yes. Now, let us go to the next topic. Tensile stress and all we discussed. Compressive stress we discussed. Shear stress we discussed. Shear stress is, remember one thing, the stress. Tensile stress is down denoted by sigma t. Can you see the screen? Can you all see the screen? Hello?
Yes, sir.
Okay. Tensile stress is denoted by sigma t. Okay. Then do not forget.
No.
Compressive stress. What? No. Any problem? Yeah, any problem? Hello. Any problem? Compressive strength stress is denoted by sigma c. Okay. Shear stress is denoted by tau. Remember this thing. Now we will go to the next topic, that is strain. So strain is what? The displacement per unit length is known as strain. Now look, strain means what? Suppose, can you hear me now? Can you hear me, all of you? Hello, can you all hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Fine. Suppose this is a bar. This is a bar of length L0. Okay. Now, on applying a force P, its length is increasing by del L, delta L. That means. Okay.
Hello.
Sir, no voice.
सुनाई दे रहा है क्या दोस्त लोग?
तुम्हारा सुनाई दे रहा है पर सर
नहीं
का
दे
सुनाई
रहे कुछ
नहीं।
भी. नहीं.
कुछ सुनाई दे रहा है? हेलो.
Yes, sir. Yes, sir. अभी सुनाई दे रहा.
अच्छा चलो ठीक है. तो ये L0 था initial length. Now if it is increased by del L, if you are applying a force P, then this length is increased by del L, right? Now if this length is increased by del L, then
वॉइस क्रेक हो रहा है.
सर आवाज
okay. If it is increased
सर
by
वॉइस
del,
क्रेक हो रहा है.
अभी हो रहा है क्रैक?
अभी ठीक है सर.
ये जियो का नेटवर्क खराब हो गया बहुत मेरा. ये देखो, हमेशा तुम लोग के क्लास पे ही होता है. एचएम का क्लास लेता हूँ वो लोग सुनता ही रहता है. तुम लोग को शायद जियो खराब पाता है ना? हेलो.
पता नहीं सर.
ओके
सर,
आप सब. हाँ बोलो. क्या बोला? हेलो.
Nothing, sir. Nothing.
हाँ बोलो, बोलना है तो. ओके, जोक्स अपार्ट, लेट अस स्टार्ट. सो दिस L नॉट एंड del L अभी सुनाई दे रहा है ना?
जी सर.
Yes, sir.
This L naught and del L. Suppose the initial length is L naught. If you are applying a force P, then this is increased by del L. Fine. If this is increased by del L, then what will happen? This L naught plus del L will give you the new length as L. Now the strain. Strain means what? The elongation per unit length or change in length by original. Is it okay? Change in length by original length is known as what? Strain. Now this strain is denoted by this epsilon. Now change in length means what? What is the change in length here? Tell me. Can you tell me what is the change in length?
डेल्टा एल
Good.
सर.
L not नहीं है, L not original length है. Someone said delta L. It is very good.
डेल्टा एल.
Okay, delta L is the change in length. So and original length is what?
एल नॉट.
So L naught is the original length. Good. That is why this epsilon, that means strain, your delta L by L naught. Now for tensile strain and compressive strain, why tensile strain is there? Can you tell me why tensile strain is there? Someone please tell me why is this tensile strain not compressive? From this diagram only you will understand.
Because sir is extend.
Ah, good. It is extending, na? This is being pulled.
Yes, sir.
If it is in this direction, then it would have been what? क्या होता?
The compressive force.
Good.
Compressive
Very
force.
good. So this is the basic concept. Okay. There is an example now. I am giving you the example in the chat box. Just try to solve. Can you see the question? Can you see the question?
No, sir.
Chat box में नहीं दिखा?
Yes, sir.
Okay, good. Try to solve it. What about others? Why only 2 or 3 people respond in the class? I'll mark all of you absent if you don't respond from the next time onwards. All of you I'll mark absent if you don't give the answers. Only 2, 3 people respond. This is not good, na? Try to solve it. बोलो.
It no one, sir.
Huh? I'm not able to hear you. অলপ ডাঙৰকে কোৱা. Speak loudly.
Into the unit quantity, sir.
Can you please speak loudly?
quantity হয় না স্যার
কি quantity?
ইউনিটলেস কোয়ান্টিটি
Yeah, this is, remember, good, very good. This is a very good thing. I was about to ask you guys. Remember one thing, strain will always be unitless. समझा? Try करो अभी. 0.001 is the correct answer. I'm going to show you now. Wait. Look at this. This del L means what? Change in length. Remember, not the length that has been increased. You have to find out del L in such a manner that you have to subtract this increase in length minus the original length. Then only you will get del L, na? Why do you simply divide this by this? Why did you simply divide this by this? You have to subtract this like this. Then you will get this, and then eventually you will get this. Is it clear? Is it clear, everyone?
Yes, sir. Yes, sir.
Yes, sir.
Good.
Sir, we can leave. No battery.